All right, so good morning, everybody. This week, I want to pick up kind of right where we were, or where you started, or what you were learning on your own last week. So I'm going to start class today with a review of two examples, just because I didn't actually lecture last week because of election day. So this week, we're going to, the review, I'm going to talk about these confidence intervals for a population mean as a review. And then the new topic we'll learn is confidence intervals for population proportion. So the lectures in the classroom this week for under week 11 are basically just a review of everything I talk about in class today, okay? Most of the videos are a little bit on the shorter end, so that's good. And we're gonna rely very heavily on our graphing calculator today. So outside of, I think we're gonna do 5 or 6 examples today. I'll do 2 examples by hand, and then I'm gonna show you how to use your graphing calculator for it. So have that handy. The good news is if you have a TI-83 or a TI-84, it doesn't matter. The screen and the inputs are exactly the same. So I'm gonna do everything on the TI-84 today, but if you have a TI-83, it doesn't matter, it's okay. So after class today, if you want, there's some review lectures here, and then you have a post-class assignment here. It's just gonna be on confidence intervals. And honestly, if right after class, if I were you guys, I would just, I would legit just like do the homework assignment and get it out of the way while it's still fresh in your mind. Okay, that being said, does anybody have any questions for me before I get started? No questions? Okay. All right, so I want to just start with an announcement. So if you look back at the syllabus says there's going to be 12 weekly post-class assignments. I'm going to modify the syllabus. I'm going to add 1. So now there's going to be 13. So what that means is your post-class assignments are going to end up counting for more than the 60% in the syllabus, okay? And your exams will end up counting less than 40%, which I think is a good thing. So just so you know how the rest of the class is going to go, your week 11 assignment, this is your 11th assignment, which is crazy, I think. It's going to be on confidence intervals for proportions, what we studied this week. Next week, there's going to be no post-class assignment. We're still going to come together and I'm still going to lecture, but there's going to be no assignment after that. And then after Thanksgiving, we will have post-class assignments for the weeks we meet of 12-1 and 12-08. That's going to be, those 2 post-class assignments are going to be on our hypothesis testing, our final topic. And then our final exam is going to be on last day of class, Tuesday, 12/15. And we're going to take that during class. So we'll actually, it won't be a take home like the midterm was. We're going to take that right during class, and I'll have more information on that after Thanksgiving. But does anybody have any questions about that for now?
I have a quick question. Can you hear me? I have a new microphone on my computer.
I can hear you perfectly.
Okay, thanks. Do you teach, what other classes do you teach?
Let's see, what am I teaching next semester? I'm teaching, I mostly teach statistics. So I'm a full-time professor here. So I teach 5-6 classes a semester. I mostly teach statistics. I think I'm teaching Calc 2 next semester. What else am I teaching? Yeah, I think just stats and Calc 2 next semester.
Thanks, I already have those.
Sorry.
Number.
Sorry. Yeah, no, sometimes I teach MATH140 or MATH138, but generally I just love teaching statistics, so it's all I generally teach. I think it's the best math class. Final exam will be open notes, yes, in the chat. But the final exam is going to be timed. Okay, so you're only going to have 2 hours to complete it. Okay, because we're going to take it during the 2 hours we have of class. And I'll post a practice one for you so you guys can see, so you all can see what the final exam is like. Okay.
Professor, I have a question.
Sure.
Are you gonna like have some sort of review session where we like go over each unit, or?
Yeah. So what'll happen is on the 8th, the topic that I'm going to introduce won't actually take all that long, maybe half an hour or something, be real easy. And then what I'll do is I'll spend the last hour of class on the 8th doing a review for you.
Okay, thank you.
Yeah, because there's been a lot that we've covered. So the final exam is going to cover 3 main topics. It's going to cover sampling distributions, confidence intervals, and hypothesis testing. So the good news is, and the good news is like this section and this section, you're going to see, especially today with confidence intervals, are very calculator heavy. Like once you recognize like what the information is given, like you just plug it into your calculator and it's going to solve it for you very easily. Hypothesis testing is kind of the same way. Just the hard part about that is like setting up the problem, because hypothesis testing is just all going to be big word problems. But I'll walk you through enough examples and then we will do a review. All right, any other questions, everybody? I get good vibes. You'll all do great. All right, so as we get ready for this lecture, for the first example here, under week 10, there was this, under lecture 1, there was this table called the ttable.pdf, and when you download it, it looks like this, okay? Do you guys remember from the videos and the homework assignment last week that I talked about how you read this table?
Yes.
A little bit, I got 1 yes.
Yes.
All right,
Yes.
So have this handy just for a second. I'm going to show you, we're going to work one example by hand using this table. And then what I'll do is I'm going to show you another example with your calculator. Okay. So just a quick review. All right. Confidence intervals for a population mean. All right. So just real quick, you know, what exactly is a confidence interval? Okay, all it is it's an interval estimate, an interval or range estimate for a population parameter. Okay, and the 2 population parameters that we're going to be talking about estimating is a population mean. That's going to be the review today. And then the new thing we'll learn is for P, a population proportion. So what I'm going to spend some time on, especially during the second half of class, is after we figure out how to like calculate these using your graphing calculator, which is, again, incredibly easy. Then I'm going to talk about like interpretation of it and how you can conclude from them, and or what you can conclude from them and what you can use them for, which I think is a little bit more interesting. And apologies in advance. My son is about halfway through his nap, so if he wakes up screaming, you guys will know exactly the same time I do. All right. No LOL for that one? Okay.
I'm a bit tired.
Is everybody okay if I move on to the next slide?
Yeah. Yep.
Thanks, everybody. All right, so here's the first example. We're just going to do a real simple one. Okay, so an economist wanted to estimate the mean commute time of individuals living in Morristown, New Jersey. Okay, so I picked Morristown because that's where I'm from. So this economist, she samples, so I'm going to write down the information as I get it. She samples 31 commuters in Morristown. So this is what you're given. You're given the sample size, 31. And she finds that the mean commute time from that sample is 28 minutes. So you're given X bar in a standard deviation of 14.3 minutes. So she also calculated S for you, 14.3, okay? And what she asks next, or what we ask to do, is I'm gonna construct two confidence intervals, okay, for the mean commute time in Morristown, New Jersey, okay? I wanna construct a 95 and a 99% confidence interval. So for confidence intervals for a mean, all right, you're always going to use this formula, right? You're going to take your point estimate and you're going to add and subtract what's called the margin of error. Do you guys remember me talking about the margin of error in the slides at all, videos last week?
Yes.
Yep. Okay. So this is going to be the same exact basic concept when we get to confidence intervals for proportion. Okay. So what a point estimate is, just recall, a point estimate is a single value estimate for the mean. Okay. So it's X bar. And then we're going to add and subtract something. And let me go back just so we're clear what's going on here, okay? What we want to do is we want to estimate the mean commute time for all people in Morristown. Okay, do you think the mean commute time of everybody in Morristown is exactly 28 minutes?
No.
It's not, right? Like this is just a sample of 31 people. It's definitely not exactly 28 minutes. It's probably pretty close to 28 minutes, but it's probably not exactly 28 minutes, okay? So the reason we do confidence intervals, we go, okay, well, if it's not 28 minutes, then like what's the real value? So the margin of error is made up of two things here, okay? You have this thing called T of alpha divided by 2 times S over the square root of N, okay? This T of alpha divided by 2 is a T distribution critical value, okay? So if you look at the table, okay, to be able to look this up on our table, you need two things. You need DF, degrees of freedom, and then you need this thing called upper tail probability, okay? Does anybody remember what DF, the formula for DF was, degrees of freedom?
N minus 1?
Yep, thank you. Just sample size minus 1. And then this alpha divided by 2, that's the upper tail probability, and I'll talk about that in a second. Okay, so let's do this 95% confidence interval first, okay? Whoop, 95% confidence interval. All right, so it's just this formula. X bar, add and subtract, T of alpha divided by 2 times S over the square root of N. So this problem is like super straightforward and easy. X bar is given, it's 28. S is given, it's 14.3. N is given, that's 31. So the only thing you have to find is this T of alpha divided by 2. Okay, that's the only thing you have to do for this problem. Okay, so for this problem, what is the degrees of freedom here? It would be what minus what?
30.
Yep, it'd be 31 minus 1, get you 30. Now you need to find this upper tail probability. So I called alpha, all right, the way I talked about it is it's like how often you're willing to be wrong, Okay, so if you want to be 95% confident, how often are you going to be wrong?
5%.
Yep. So alpha then would be 0.05 divided by 2, which would be 0.025. So look, this is piece of cake how you do this problem. Using this table, you just go degrees of freedom down to 30. Do you guys see it on my table? I know it's a little small. And then you're going to go over till you get the upper tail probability 0.025. There's another way you can do it. Do you notice how at the bottom it says confidence level? It's also, you can just look at confidence level 95. So what is my T critical value here?
2.042.
2.042. All right, so this is just a plug and chug now, okay? It's 28, add and subtract 2.042 times S, which is 14.3, over the square root of 31. So grab your trusty calculator that never lets you down. It's always there when you need it, like for a ride to the airport or something. So do the margin of error first. It's 2.042 times 14.3 divided by the square root of 31. And you get this, if anybody's following along.
Yep.
Yep, I'll just go to 5 point. I'll just round it to one decimal place. It's 5.2. All right, so a confidence interval has a lower bound, which is the subtraction part, which is 28 minus 5.2. Oh my gosh, why am I so bad at math? Because it's early and I've only had a couple cups of coffee. 22.8. And the upper bound is the addition part. Is 28 plus 5.2, which I think gets you 33.2. All right, so this is what we're saying. We're 95% confident that the mean commute time of everybody in New Jersey is somewhere between 22.8 minutes and 33.2 minutes. All right, so I ring a bell from last week doing this?
Yes.
Yes.
Okay. Let me just quickly do the 99. It'll take me 2 seconds to do. Is everybody okay if I go to the next slide?
Yes.
Yep.
Okay. So now same problem. Let's do a 99% confidence interval. So these things don't change, okay? X bar is still 28, S is still 14.3, and N is 31. The only thing that's going to change is my critical value here. So this is how I would actually do this problem, okay? I wouldn't even worry about like the upper tail probability if you're going to look it up on the table. So the degrees of freedom is still 30. Okay, that never changes. But now for a 99% confidence level, look at the bottom of my table, confidence level, 99. So 30, shoot over to the confidence level of 99. Do you see this number, 2.750?
Yep.
That's my critical value. So now it's just a plug and chug problem, okay? So it's 28, add and subtract 2.750 times 14.3 over the square root of 31. So you're going to do your margin of error first. 2.750 times 14.3 divided by the square root of 31. And you get 7. I'm just going to do 7.01 here. I'll round it. Or 7.1, excuse me. So the lower bound here is the subtraction part. I think it's you 20.9. And the upper bound is the addition part, which is 28 plus 7.1. I think gets you 35.1. All right, so we're 99% confident then that the mean is somewhere between 20.9 and 35.1. All right, so just going back to answer the last question, what happens to the width of the confidence interval as you increase the level of confidence? So as you increase the level of confidence, okay, so here I went from 95 right here to 99 here. Did the interval get wider or narrower?
Wider.
Yep. The confidence interval width increases. Okay.
So can you go back a slide just 1 second?
Yeah, sure. Here?
Thank you so much. Yeah, just 1 second. Oh, thank you. Yeah, I got it. I just wanted to make sure that I have the right number. Thank you.
Yeah, you're welcome. Okay. Not too bad. Piece of cake, actually, do we think?
Yeah, pretty easy.
Okay. So here's what I want to do now. I want to show you a problem I gave on last year's final exam. Okay. So you can see like what the problems will look like. Is everybody okay if I go to the next slide?
Yes.
Yeah.
Yep.
Okay. Here's last year's problem on last year's, okay? So in 1908, W.S. Gassot published the article, The Probable Error of a Mean, okay? In this pioneering paper written under the pseudonym Student, Gassot introduced later what later became known as the student's t-distribution. So this is the mathematician who actually discovered the t-distribution, and this was the actual paper that he talked about in it. All right, so Gassot used the following data. Okay, so you have a table of data here, which gives the additional sleep in hours obtained by a sample of 10 patients using this drug. Okay, I'm not even going to try to pronounce it, okay? So I'm just going to call it LH, okay? And so what you see here is this is the actual data for additional sleep people on the drug got. Okay, looking at these numbers, I might have to give it to my son, right? Because last night he was up like a bunch. Now, that was a joke. That was a joke. Don't report me to child services. Okay.
Haha.
Thank you for the pity laugh. All right. So I'm going to show you how to do this all in your calculator very easily. Okay. So the first question says, construct a 95% confidence interval for the additional sleep that would be attained on average for all people who use this drug LH. Okay. So do you notice the subtle difference here? Like in this problem here, I gave you like the mean and standard deviation. Here, I just give you the raw data, okay? Well, the good news is your calculator will literally do everything, okay? So I encourage everybody who has their TI calculator here to take it out and just follow along with me, Okay, because you are able to do this on the final exam. Like you don't necessarily do things by hand. You can use your calculator. So the first thing I want to do is I want to take this data right here and I want to input it into my calculator. So I'm going to hit, everybody who's following along, hit the stat button on your calculator. And I know it's been a while since we've actually done something like this, but under number 1, edit, you want to edit the list, okay? How many people have data here in their calculator, just out of curiosity?
Yeah, data.
Okay.
Yeah, I have to.
That's okay, no problem. Here's what you do not want to do. Please do not do this. Does anybody not see L1 up there? Just out of curiosity. Does everybody see L1? That's really important too.
Yes.
Okay. To clear data out, you scroll to the top. Do not. Okay, this is like me trying to be like, do not do this. Do not hit delete. If you hit delete, I'll be angry. You're just going to hit clear and then enter. Okay, clear, then enter. So now you should have a blank list of data. Now let's start putting this stuff in. It's like 1.9, 0.8 extra, got an extra 1.1 hours. This person only got an extra 0.1 hours. This person lost 0.1 hours. Ugh. This person got an extra 4.4 hours, must be nice. Extra 5.5 is even better. 1.6, 4.6, and 3.4. Okay, so you have your 10 data values put in. Now the next thing you're going to do is you're going to hit the stat button again. Okay, so everybody hit the stat button. And over the next month that we have left of class, which is going to go really quickly, we're going to scroll over to this thing called tests. Okay. And you see legit all these options here. Okay. These things called z-test, t-test, 1 prop z-test, 2 prop z-test. This is going to be for hypothesis testing. Okay. So we want a confidence interval. So because you're not given the population standard deviation, you're just given like raw data, you're going to want option number 8. So you're going to go down to t interval. Okay. So everybody go to t interval. I'm going to hit enter. So there's 2 options here. All right, you'll see up at the top. And I'm going to pause for a second. Does anybody need me to go back to that, or I realize I went through it pretty quickly?
You're good.
Everybody good? Everybody else good?
Yeah.
Okay, there's 2 options. There's option number 1 for data. That's if you have the raw data, which we do. Option number 2 is if you have the summary statistics. Okay, so we have the raw data. It's put in list 1. So I'm just going to hit enter. I'm going to scroll down. It's in list 1. Don't worry about frequency. The C level, that's your confidence level. The calculator always defaults to a 95%. Okay, but if I ask you like 99, you just have to change this to 0.099. Okay, but did ask for 95. And then you're just going to hit calculate here. How many people see this?
Yep.
I get that.
Everybody who's got this? So
Yeah.
what this calculator just did for you is the formula that we've been doing by hand. It just says, yeah, no problem, I'll take care of it for you, okay? And this right up here is your confidence interval, okay? So the lower bound here is 0. I'll round it to 2 decimal places, 0.90. And the upper bound is 3.76. Okay, so used calculator. And these were the options we did. We pressed the stat button, we went over to tests, and then we went over to T interval. Okay, so this is what we're saying. Okay, we're 95% confident all right, that on average, the additional sleep people will get by taking this drug is somewhere between 0.9 hours and it could be as high as 3.76 hours, and it's everything in between. Okay, let me ask you this. Is at least using the calculator, was that pretty straightforward?
Yeah.
Yeah.
A lot easier than doing it by hand?
Much
Yeah.
easier.
Yeah, and you're more than welcome to use the calculator. Okay, statisticians don't do this stuff by hand. They just have technology do it for us. So that's what we're going to do. But now here's the next question. Okay, so let's see if we understand what this told us. Was the drug effective in increasing sleep? Yes or no?
It seems
Yes.
like
Yeah. How do you know though? Like why?
Because they got on average between 0.9 and 3.76 extra hours.
Yep, that's it. Yes, absolutely. Yes, it was. And this is because our confidence interval is above 0. Okay. All right. Like if we had done this problem and my answer had been anywhere from negative 0.25 to say 3.25, notice how 0 falls between these two numbers. Then we couldn't say, well, then we couldn't say it's effective at increasing sleep because they could get 0 on average. But because our confidence interval is all strictly positive, absolutely, this drug was good at increasing the amount of sleep people get. All right, so seeing this, does it seem like you could handle a question like this on the final?
Yes.
Yeah.
Yes. Yeah.
Okay, good. So the final exam is going to be, just to give you a heads up, it won't be as many short problems like this. Like this is just stuff to introduce the topic. It's going to be more problems that look like this. Okay. I'll ask you to construct the confidence interval, and then I'll ask you like a quick follow-up question about it. But the good news is you'll be able to rely very, very heavily on your calculator, legit for every single problem on the final exam. All right, so before I move on to the next topic, does anybody have any questions about that for me?
I have a question just out of curiosity.
Yeah.
When I put 100% confidence interval,
The only way you can have 100% confidence interval is you'd have to say it'd have to be all real numbers. Like statisticians never do 100% confidence intervals.
okay, the calculator showed pretty narrow value and it's not credible, right?
Like if you change this to 100%, like you put in 1 here, like this. No, that is not correct at all.
Okay, thanks.
Yeah. So don't do that. All right, any other questions for me? Okay.
Yes, Professor, sorry, I have one question.
Of course.
Is it possible for us to get like for the upper bound to be higher than the lower bound in any of the question?
No.
Okay.
No.
Okay. Thank you.
Yeah, no problem. And in your calculator, if you put everything correctly in your calculator will never make a mistake for you. Okay. The only way you'll make a mistake on these problems is if like you accidentally input something incorrectly. All right. Let's go now talk about confidence intervals for a population proportion. And let me just kind of set this up for say 10 minutes or so. And then we'll take a quick break. I'm going to refill the coffee and then we'll come back and just work examples for the time we have left. All right. All right. So this is kind of just a review of confidence intervals, just so we're clear. Okay. As we go through this. So the objective of estimation is to estimate the unknown value of a population parameter, right? So like a population proportion P on the basis of some sample statistic from sample data. Okay, so we use sample data. To estimate for a population. Okay, so unfortunately, you can kind of tell that this is an old slide because COVID doesn't have, this wouldn't be effective with COVID anymore. But suppose the WCC Student Affairs Office wants to estimate the proportion of students that want more campus weekend activities, okay? So they want to estimate some P, okay, some population parameter P is the proportion of students that want more campus weekend activities. All right, so there's two types to estimate, right? You can do a point estimate, which is the single value estimate. Or you can do this interval estimate, okay? This is the confidence intervals that we were just doing. Everybody okay if I go to the next slide real quick?
Yeah.
Yep.
Yes.
All right, so the point estimate of the population proportion we've talked about before, okay? And does anybody remember what this is called? It looks like P with a little hat on top of it.
P hat.
Yep, this is called P hat. Okay. And all P hat is, if you want to estimate the sample proportion, okay, P hat is just equal to the formula X divided by N, okay? Where X here, all right, is the proportion of X successes. And what I mean by that is it's the number, X is the number of people who have a certain characteristic. And you're going to divide that by N, which is the sample size. Okay. So P hat is the point estimate for some population proportion P. Okay. It's just like how X bar is the point estimate for some population mean mu. Okay, it's just real simple, P hat here. Everybody okay if I go on?
Yes.
Okay. So let's kind of work through this example. Okay, so we want to again estimate the proportion of students who want more weekend activities at WCC. So I sample 1,000 students. So that's my N. And of that, 590 say, yes, absolutely, I want more weekend activities. I'm sick of being locked up in my house.
Yes.
Actually, that's bad. We should all stay in a little bit longer. So look, the sample proportion then would be P hat is just X divided by N. It would be the 590 people who are like, yeah, I want more weekend activities divided by the 1,000. It's 0.59, okay? So now here's my question for you, all right? And this is why we need confidence intervals. Do you think exactly 59% of WCC students want more weekend activities?
No.
No.
Nope, it's not 59%. It's probably really close, okay? But like, it's not exactly 59%. That's the whole point of statistics. Like it's close, it's a good estimate, not the real value, okay? So what could the real value be then, okay? So again, there's like no way I could call every WCC student and say, hey, do you want weekend activities? Do you want weekend activities? Da, 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 da. You can't do that. All right, so we're going to estimate it then. So here are some of these shortcomings of this point estimate, as I was saying, okay? Best estimate for the population proportion. All right, but like how good is this estimate? Okay, so there's like no measure of like how reliable it is, like how close it is to the real value. So there's another type of estimate that we're talking at, and this is the confidence interval, okay? So how do you construct a confidence interval for P, okay? So if you downloaded the slides, I have the formula on the next page, but I actually just kind of like want to walk you through it real quickly, okay? So a confidence interval, okay, it's a range of values. A confidence interval, no matter if it's for a mean or for a proportion, legit always starts the same way. It's always the point estimate, add and subtract the margin of error. So the margin of error, or excuse me, the point estimate here for a proportion is just the sample proportion. A margin of error, okay, is always, always, always made up of two things. It's always made up of a critical value times the standard error. Always, always, always. And like, I'm just gonna go back really quickly just so you can see something. Like this is our critical, this was our confidence interval. The margin of error is the critical value times the standard error. Like that's what these two things are. So the notation here is a little different, okay? And this is where this formula at first seems a little daunting, but it's really not that bad. So our formula, the sample proportion is P hat. And then we're gonna add and subtract something. The critical value here is no longer a T, okay? So we don't use the T distribution here, never do, okay? It's always Z of alpha divided by 2. And I'll show you how to find this very, very easily, okay? The standard error is simply given as the square root of P hat times 1 minus P hat over N, okay? And this right here is our confidence interval formula. Is everybody okay if I go to the next slide real quick, or do you still need to copy?
Yes.
Fine.
It's fine.
Okay. So I'm going to show you how to do these problems. And just like the confidence interval problems for means, it's just like a plug and chug formula, okay? If you look at this formula, there's only 3 things in it. There's P hat, so we've got to be given P hat somehow. We've got to be given the sample size, that's the second thing. And then we just have to find this critical value, Z of alpha divided by 2. Well, if you look here, all right, on this page right here, do you notice how I say confidence levels, and then over here I give Z critical values? Do you see these?
Yep.
Yep, so you can just use this table right here. Okay, so like for example, if I want a 95% confidence interval, I'm just going to use the number 1.960. If I want a 90% confidence interval, I'm just going to use the number 1.645. That's it, okay? If I want a 99% confidence interval, I'm just going to use the value 2.575. And this is only if you're going to do it by hand, okay? So I'm going to show you how to do this by hand once, and then I'm going to show you how to do it with your calculator, okay? How about I show you how to do it by hand, and then we'll take our break, and then we'll come back and we'll just work all with our calculator. Does that sound okay to everybody?
Sounds good.
Yeah.
Okay. Boom, boom, boom. All right, so I'm going to do a couple examples. Here's the first one, okay? So just recall, we wanted to estimate the proportion of students who wanted more weekend activities. Okay. Does anybody remember what p hat was for this? It was what divided by what?
X
X over N.
Okay, and what were the actual numbers?
590 over 1,000.
Okay, yep. So look, just by this, you're given p hat is 0.59, and you're also given the sample size, right? Like how many students did I talk to?
1,000.
Yep.
Oh, God.
All right, so let's do two things. Let's construct and let's interpret. Let's actually do a 99% confidence interval. For P, okay? All right, and what P is, it's the actual proportion of students that want weekend activities, okay? All right, so whenever you're given a P, all right, and I'm asking you to find a proportion and a confidence interval for it, you're always going to use this formula right here. So it's P hat, add and subtract your critical value, Z of alpha divided by 2, times the square root of P hat, 1 minus P hat, over N. All right, so the good news is this is literally just a calculator work problem now, okay? So P hat is 0.59. Add and subtract. Now this critical value, Z of alpha divided by 2. All you have to do is go back to this chart right here, okay? If I want to be 99% confident, all right, what critical value am I going to use?
2.575.
Right there. And I need to take this and multiply it by the square root of P hat, which is 0.59, times 1 minus P hat, so 1 minus 0.59, all divided by 1,000. Okay, I know it seems silly for me to say this, but I've been doing this a while, okay? Oh God, how long have I been teaching? 11, 12 years, maybe 13, I don't even remember anymore. Okay, they all go so quickly. For as long as I've been doing this stuff, students who miss this problem miss it because they just don't know exactly how to plug it into your calculator. So I highly encourage you to follow along with me and watch me as I plug this into the calculator, okay? So what we're gonna do here is we're gonna start backwards. We're gonna figure out what this is, okay? So I'm gonna go second function square root. I'm going to take 0.59. I'm going to multiply it. Now you can figure this out ahead of time if you want. Like, does anybody know what 1 minus 0.59 is?
0.41.
Yep, that's the easiest thing to do. But if you don't, recognize that, you can just start at parentheses, go 1 minus 0.59, close the parentheses, and then divide it by 1,000. How many people get this number right here? 0.015555.
Yeah.
Yeah.
Okay, if you're not getting it, it just means you're plugging something incorrectly into your calculator. And I wish like we were in person, because then I could like walk over to you and be like, oh, this is your error in your calculator. But like you just have to practice with it a little. Now I need to take this and multiply it now by 2.575. So I'm just going to hit times 2.575. And I'm going to get this. All right, how many people get this number right here?
Yep.
Okay, so I'm just going to go to 2 decimal places here. It's 0.04. Okay, so the lower bound of the confidence interval is 0.59 minus 0.04, which is 0.55. And then the upper bound is 0.59 plus that. So plus 0.04, which gets you 0.63. Okay. So all I've done now is I've constructed it. All right, now let me provide you the interpretation of this. Based on this sample, we are 99% confident, because that's what we constructed, a 99% confidence interval. We are 99% confident that the proportion of WCC students who want more weekend activities is between, it could be as low as 0.55, so it could be as low as 55%, okay? So it's somewhere between this and 0.63, so it could be as high as 63%. And that's it. That's the whole confidence intervals for proportion. It's the same exact concept, just different formula. What do we think? Not too bad, bad?
Not too bad.
Gonna need to see just a few more examples.
Yeah.
So the good news is this, okay? I'm gonna show you how to do this in your calculator, right? Like, let me go back real quick. When we were doing these 2 problems, okay? Was it a little bit, I mean, even though we had a formula for it, was it just still easier just to jump right to your calculator?
Yes.
Yeah, like it's always easier to go to your calculator. So look, we've done one of these by hand. Okay, here. What I'm gonna do now is I'm just gonna show you guys how to use your calculator for this stuff, because I think that, you know, gosh, calculator for this stuff is actually incredibly easy. And then we'll focus a little bit on interpreting results and stuff like that during the second half of class. Sound good?
Yep.
All right, let's take a break. No, I don't want to do that. All right, let's come back at 10:05 a.m. So we'll take a 10-minute break, okay, everybody?
Yep.
All right, I'll see you guys then. All right, everybody. You guys ready to? You all ready to finish up for the morning?
Yep.
I hear you. So what I want to do is I'm just going to do 3 more examples, and we'll rely heavily on our calculator for the first 2, and then the third example is going to be kind of like just a thought kind of example about confidence intervals. All right, so here's example number 2. So I came across this article by Pew. Can't spell today. An article by Pew Research. Just out of curiosity, has anybody here heard of Pew Research before?
Yes.
Yeah, they're like a survey research firm out of well, they have offices everywhere, but they're out of DC. So an article by Pew Research examined online social media habits by adults aged 19 to 29 years old. Okay. And what they found was, okay, among a sample of 929 adults, and this is just aged 19 to 29 years old, 836 of them, they used social media daily. What do you guys think of that? Okay. The numbers seem high, seem low. I'm still
Probably
on
more
break.
like-
Say that again.
Probably more like, it's probably low.
I mean, I have a Facebook account. I check my Facebook every day. So let me ask, this is just a bunch of questions about this. So the first one, let's obtain a point estimate for the proportion of adults age 19 through 29 who use social media daily. Okay. So what is the point estimate for P? What did I say that was called?
Yeah.
Yeah.
Okay, and it's just X divided by N. So how many kids, how many adults age 19 to 29 use social media daily?
836.
Okay, and how many people were in the sample?
929.
Okay, so let's grab our trusty calculator real quick. This is just 836 divided by 929. Do you get 0.89989?
Yes.
Yeah, so I'm just going to round this to 0.90, okay, because it's so close.
Professor,
Yeah.
a quick question. My calculator gives me a division when I do that. I'm sorry.
So it
Can
shows
I change that mode?
it shows it as a fraction. Is
What
that
was that?
how does it show it to you as?
As a fraction.
So you're going to have to click mode and then Do you have a TI-83 or TI-84?
TI-84.
Okay. When you click mode,
Okay.
do you see it as normal? Does it say normal here?
Yes.
Okay, let's see what else. Do you mind if we try resetting your calculator real quick?
Okay, I can try that. Yeah.
Okay, so hit second function memory. So second function memory. And then press the options 7, 1, 2.
Wait, where is memory?
Do you see the plus sign?
Oh, I see it.
And then just go 7, 1, 2.
Yep. Run clean.
Now try it and let me know.
Okay. Yep.
It worked?
Yes. Thank
Okay,
you.
You're all set. Yep, no problem. Okay, so 90% of adults in this age group use social media daily, okay? I am no longer in that age group, but I am a daily social media user. Don't judge me. All right, so now let's do the following. Now let's construct and let's interpret. Let's do a 90% confidence interval for the proportion of adults aged 19 through 29 who use social media daily. Okay. So you could do this by hand, okay? But I'm going to show you how very, very, very easily to do this in your calculator, okay? So everybody grab your calculator. It doesn't matter if you have the TI-83 or the TI-84, it doesn't matter, okay? So everybody hit the stat button on your calculator. So stat, and then scroll over to test, okay, or tests. When we started class an hour ago, when we were doing these intervals, we used option number 8, correct? The T interval.
Yes.
Whenever you're dealing with a proportion, and let me go back here. I say don't use T-stat here. You're using a Z critical value in these things, okay? So you're gonna want for this one, option number 7. So scroll down to Z interval. All right, everybody Z interval, option number 7. And just hit enter. Oh no, I'm sorry. Oh my gosh, no. Holy cow. Stats, go over to calc. I'm so sorry, I'm having a rough day. Don't listen to me. You don't want Z interval. You want to scroll down. Holy cow. You guys ever have a rough day? I'm having a rough day. You want the option number 1 prop Z int. Okay, that stands for proportion Z interval. I'm sorry about that. So we have 1 prop Z int. 1 prop Z int. Hit enter. And how many people see this on their screen?
I do.
Okay, did I mess that up? Did people need to hear me do that again? Or is everybody with me?
Can you do it again, please?
Yep. So you're going to press stat. You're going to go over to tests. And you're going to scroll down till you get to A. And you should see 1 prop Z int ... Okay. Now just hit enter. How many people, does anybody not see this now?
I see it.
Everybody's good? So look, this can't get any easier. X is the number of people who have that characteristic. So there were 836 who said, yeah, I use social media daily. N, that's my sample size. Well, there were 929 people in this sample. Your calculator will always default to 0.95, okay? But when you look back at the problem, what level of confidence did I want?
90.
90.
You just have to change this to 0.90 and then hit calculate. How many people got this?
Yes.
I did.
Okay. You know what? You see this up
I
here,
got-
this first part right here? That right there is the confidence interval. Okay. So easy to do it with the calculator?
Very.
Yeah.
Okay. So let me just write in the notes what you use for this, okay?
Mine says quit domain.
So what that means is something you inputted in your calculator is a little off. Like if you go back to stat tests, do you have like 9D instead of 0.9 here?
Mine says 0.9.
Okay, do you have these two numbers backwards?
No.
So you have exactly this.
Hold on, let me just go back.
Yeah.
Okay, I think it worked.
Okay. Yeah, usually when you get a domain error, it's just something, you inputted something wrong, that's all. And it's not a big deal. Okay, so we did in calculator, we pressed the stat button, then we went over to tests, and then we used the 1 dash prop Z int. Okay, which stood for interval. And what it gave us here is I'm just going to go to 2 decimal places. It's 0.88 to 0.92 when I round it. So your calculator just did that formula for you. Okay, it was amazing. It just solved it for you. So now we're just going to interpret this, and it's just based on this sample. We are 90% confident the proportion of adults age 19 through 29 who use social media daily is somewhere, it's going to be between 0.88, so it could be as low as 88%. And it could be as high as 92%. So now that you've seen it with the calculator, like incredibly easy.
Yeah.
Is everyone like, Matt, why don't you just start teaching with the calculator first? But like the good news is that this just does it for you, and you can use this on your final, and you can use it on the online quiz this week. So it's super straightforward. Anybody okay if I go on now, just to do 2 more quick examples?
Yep.
Anybody still copying? Okay. So 1 more quick example. So here's the context of the problem, okay? Matt, that's me, believes a majority of students love taking statistics. Okay? What do you guys think? Do you love taking statistics?
Oh yeah.
Yes.
I mean, that I can't believe only 2 people said yes just there. Okay, even if you're gonna.
Yes.
I
Maybe.
did.
No, it's too late. You guys are all getting a really hard final exam. Okay, broke my heart just now. Oh, that's a joke. I've already written the final. All right. So first off, in terms of proportions, okay, what constitutes a majority? Greater
Over
than what
50%.
Say it louder.
Over 50%.
Okay, so Matt believes that over 50% of students love taking statistics. Okay, that's his belief. Okay, so I want to test my belief. All right, he samples 400 statistics students. And finds that 216 love taking statistics. Okay. So I've got a couple questions for you here, okay? First, obtain a point estimate for the proportion of students who love taking statistics. Okay. All right, what is the point estimate for the proportion here called again?
P hat.
Okay. And it's x divided by n. So in this case, it would be what 2 numbers divided by each other?
216 over 400.
So we're going to take 216 divided by 400. And what did I get here? 54. Okay, so this is what I'm saying. I estimate that 54% of students love taking statistics. Okay. Great. Awesome. So let me ask you this. Is 54% a majority?
Yes.
Yeah, it's greater than 50%, right? So here's the thing. I want to show you now, talk to you about the shortcomings of statistics here a little bit, okay? So you take this sample of 400 students and 54% of them said, yeah, of course I love taking statistics. But here's the crux of the problem. If I were to sample another 400 students, is it likely that I would get exactly 54% of them who said they love taking statistics?
No.
No.
It'd probably be different, right? And this is just an estimate of 400 students, okay? So, to just say that from a 400 statistics students, that exactly 54% of all statistics students love taking stats isn't really correct. Okay, so that's why we need to say, okay, well, if the real value is probably not 54%, what is it? Okay, so let's construct a 95% confidence interval now. For the proportion of students who love taking stats. Okay. What's the easiest thing to do here? Calculator or by hand?
Calculator.
Yep. So the options again, where you use stats, you go to tests, and then it's 1-prop z int. So I'm going to stats. I'm going to go over to tests. You got this 1 dash prop z int. So the TI-84 saves the data, so you just have to input over it. 216 of the 400. And what confidence level for this problem did I just say to do?
95.
95.
Yep, so you have to just change this to 0.95. And how many people see this result on their screen?
I do.
I do.
All right, so this is what I'm going to do. I'm going to round it to 2 decimal places. So my 95% confidence interval is 0.49 to 0.59, okay? So now here's my question. Looking at this confidence interval. Does the confidence interval support Matt's theory? Yes or no? What do you think?
Yes, because his estimate falls within that interval.
Okay. All right. Anybody else?
Well,
No.
isn't the majority over 50% and the lower is under 50%?
Yeah. So here's the thing, and this is why you have when you see like polls on television, you like really have to pay attention to the margin of error. Okay. So look, I talked to 400 students and I said, oh yeah, 54% of them said they love taking statistics, but that's not the real value. Okay. It's probably close to that, but that's not the real proportion of students who love taking stats. So what is the real proportion? Well, there's no way we could know this. So our confidence interval tells us, well, look, I'm 95% confident. It could be as low as 0.49 and every number in between 0.49 to 0.59. So 0.491, 0.49001, everything, 0.499999, okay? Do you notice how the bottom part of this interval is less than 50%? Right? Like,
Yes.
it could, the lower value could be, it could be 49% of students love taking stats, which is not a majority. Like even though most of the interval is above 50%, some of that interval is still below 50%. So it could be, like that's the whole point of confidence intervals. The real value could be less than 50%. It could. So does the confidence interval support Matt's theory? No. Okay, so even though I think that a majority of students love taking stats, our confidence interval says it could be as low as 49%. Okay, so you just have to be careful of that. Like whenever you see, something in the news where it's like, oh yeah, 54% think this. Well, like look at the margin of error. Okay, that's the important thing here. Speaking of the margin error, just one last question here. What is the margin of error for the confidence interval?
.5.
Say that louder.
0.5.
How'd you do? You absolutely got it right. How did you do it?
I substituted the max and low interval from the mean value, sample mean.
Yep. So the margin of error, I'll just give everyone a quick formula for it. Margin of error. You can just take your upper bound, and subtract away the point estimate. So my upper bound was 0.59. My point estimate was 0.54. So the margin of error for this survey I did is 0.05 or 5%. So just always pay attention to that margin of error. Okay, it's like incredibly important. All right, does this example kind of make sense?
Yeah.
I have one of the videos I have recorded this week works another one of these majority problems, so you can see see how it's done again. All right. Well, let me just say this real quick. Calculator easy for finding these confidence intervals?
Yes.
Yep, piece of cake, right? Everybody should get 100 on the quiz this week.
Oh yeah.
All right, let me just, so here's what I want to do. I just want to do one quick example and then I'll talk about your quiz this week, okay? All right, last example. You guys hear my chair every time I move, by the way?
I didn't hear it.
Like that?
I do.
Yep.
Yeah. I have the worst chair ever. My chair's like 10 years old. My wife keeps wanting to buy me a new one, but I won't let her. Because I've worn this one.
You need WD-40, Professor.
I need some WD-40. But my chair is so comfortable, you know, it's like conformed to my body. Okay. Here's the last example. And I just want to talk about, it's a little, I want to talk about the numbers related to politics. I don't want to talk like about politics, okay? So like, if you guys paid attention to the news, like polls have been talked about in the news a lot recently, right? Like the polls underestimated the president's support in the last election. But so I just want to talk about in some old polls. So I have data or slash some polls from 2013. And this is when Obama was president. Missed that guy. Okay. And so I have two polls. It was a good guy. Liked him. All right. So I have two polls. I have one by Gallup. Have people heard of Gallup? Gallup organization? They're just another survey.
Yep.
Yeah, they're just another survey research firm. And I have one by Quinnipiac University. So Quinnipiac University, I think they're in Connecticut. But what they do national survey research. They do national political polling. Okay, so anyways, both these polls asked the question. This was in 2013, okay? Do you approve of the president's handling, let's see, let me get this right. No, do you approve of the president's handling of the economy? Okay, this was in 2013, okay? And here's what happened. In the Gallup poll, they came out and they said, 42% of people said, yes, I do approve, okay? And their margin of error was plus or minus 3%, okay? Quinnipiac University came out with the same poll, okay, during the same time period. And their polls found out that 38% of people said yes. And their margin of error was plus or minus 2%. Okay. So here's my question, okay, from this. Could both polls be right? So Gallup said 42% of people approve of the president's handling of the economy. Quinnipiac University said 38% of people approve of the way the president was handling the economy. Okay, those are two different numbers, right? 42, 38, they're close, but they're different, you know. So my question for you is this, right? Can anybody tell me if they think both polls could be right, or is only one poll going to be right?
Both can be.
They
Okay,
can both be right.
How could both be right? I don't know. I mean, you get two different numbers.
And different people have different opinions, and they're probably asked different people.
So here's the thing, right? Like, what we're trying to do with this question here is we're trying to estimate the proportion of every single person in America who approves of the president's handling of the economy, okay? So Gallup called a bunch of people and they said, that real value is 42%. Quinnipiac University called a bunch of people and said, hey, that real value is 38%, okay? So like, I'm going to give you a hint. Both polls could be right, okay? But all right, so I gave you the poll numbers. What other piece of information did I give you about each poll?
We have the margin of error, and if the margin of error includes or like they overlap, then they can both be right.
That is exactly right. That is what I'm hitting at here, okay? So Gallup, all right? The Gallup poll here, if you take the margin of error, so whenever you see, what I'm hitting at here is whenever you see a poll like in the news and they give you the margin of error, you can construct a confidence interval from that, okay? So this confidence interval, okay, subtracting the margin of error, you get down to 39%. Adding the margin of error, 3% to this, it could 45%. So what Gallup is really saying is my point estimate was 42%. But what could the real value be? Well, the real value based on the margin of error could be anywhere from 39% to 45%. Quinnipiac University, when they released this poll, is saying, yeah, 38%. That's my point estimate. But when you add and subtract the margin of error, so subtract 2% here, you get 36%. Add 2% to 38%, you get 40%. Do you notice how these two overlap a little?
Yes.
Yeah, since they overlap, if the real value, okay, if the real value was somewhere between the overlap between 39 and 40%, both polls could be absolutely right, okay? So that's why it's incredibly important to pay attention when you see polls in the news to the margin of error, okay? Just don't take like the point estimate at face value. Like in this example here, when we went back, 54% of students love taking stats. Well, I don't really know if you could say a majority because it could be any numbers in between here. And even though these two polls got two different answers, because their margin of error is overlap, they both could get it right. So I don't know. I find that interesting, I think. I hope you guys do.
What does it imply? What does it imply when the poll errors are always in one direction? Overestimated or underestimated? Is there a flaw there somewhere?
So are you asking about the presidential election? Is that what you're asking? You can, yeah,
Yes, this one and the last one.
Sure. So I'm very fortunate. I think you guys have heard me say this, but I'm married to a pollster. Did I ever tell you guys that?
Yes.
So my wife does this for a living. So I'm privy to like having a lot of intellectual conversations with her about it. So if you're interested, I'll talk about I'm going to turn off the recording for that. But let me just talk about the exam real quick, okay? Or your quiz this week. And then I'll answer your question because it's actually very interesting, okay? It's a little bit higher level statistics. So your quiz this week, you'll notice it's 6 questions when you go to take your quiz this week. It's 3 different confidence interval questions, all right? The first question will always ask you what's the lower bound of the interval. The second question will ask you to plug in what's the upper bound of the interval, okay? Just pay attention to the 90% level of confidence, okay? 99 here, and then question 5 is a different example from the first 2. Okay. You get 2 attempts at it. So, you know, after you take the attempt, you can see, you know, like what I got wrong and things like that. But I encourage you actually like right now to go do the homework. Okay. So I'm not going to talk I'll stop the recording and I'll answer your question now.